In this lecture, I'm going to be talking more specifically about meteors and what happens when meteors enter our atmosphere. So, um, we see this happening all the time. These are actual photographs here and here of things like we would often call shooting stars, where you hear about meteor showers, and this is what happens, what we can see in the sky when meteors hit the atmosphere. You may have heard of falling stars. Any of those kind of things are meteors hitting our atmosphere. Now, when that happens, these meteors are moving extraordinarily fast. They hit the atmosphere, and suddenly there's a tremendous amount of friction. And that friction is going to cause the rock, or whatever it is, to heat up. And that's what makes it glow. And some of it is going to eventually even melt off and trail off into the atmosphere, and that's where we can see these tails. Sometimes, depending on the shape of the object, it will completely burn up. The entire thing will melt before it hits the ground, and then we just have a meteor and not a meteorite. Another thing that can happen is that because these objects are not exactly regularly shaped, they're not perfect spheres or anything like that, they have holes in them and irregularities. Different parts are going to melt at different rates. And so you can have areas break off because the area around them has melted away. And so this can cause the meteors to break apart, and then maybe some of the little pieces burn up, and it's possible then that some of the big pieces could hit intact. Sometimes, depending on the exact characteristics, you can even get them to blow up completely in the atmosphere. They literally explode. So all of these different things are possibilities. This is a figure from your book, 1225, and this is a really, really, really important one that I want you to be aware of. This gives you a sense of how often we get hit by meteors of different sizes. And it also gives you a little bit of a sense of what the effects are, which I'm going to go into in more detail on the next slide. So you don't necessarily need to focus on the effects right now, but look at the sizes and then how often these things occur. So if we start with ones that are a meter big, you know how big a meter is. And if you look at this, this happens between a day and a year, so several times a year, many times a year, the Earth somewhere gets hit by a meteor that is a meter across. A 10-meter one, so size of a room, let's say. Well, every century or so, we get one of those. And those can give you atmospheric explosions. You can start getting some craters out of ones like that. There's a famous historical one that we're going to talk about. Every 1,000 years or so, we get one that's 100 meters, so football field size. This is where we're going to start getting dangerous. If you start getting ones this big, you can cause devastation to an area, say, the size of a city. You can cause damage to. So this can almost have the effect of a nuclear bomb. One that's a kilometer across hits about once every million years. And you can start getting some really, really widespread impacts from that. You start getting some really serious issues. If it hits in the ocean, you get tsunamis. Got a 70% chance of it hitting an ocean, and so tsunamis obviously are very dangerous. If it hits on the land, you can cause gigantic dust clouds and fireballs that can destroy miles and miles and miles of area. So we're getting into seriously dangerous here. Somewhere between 1 and 10 is about where we get one that's big enough to kill the dinosaurs. We talk about mass extinction. That's talking about where a substantial portion of all the life on Earth dies, where thousands and millions of species die off completely. So it wasn't just the dinosaurs, of course, but many, many other things that were alive at the same time as the dinosaurs also went extinct. That happens every 100 million years or so. The dinosaur killer was about 65 million years ago. And then finally, one that's big as 100 kilometers or more might happen once in the entire history of Earth. There just are not that many asteroids that are that big, and the chances of one actually hitting us are extraordinarily small. But if that did hit, that would be something that would definitely wipe out life on Earth. So this chart is just another way to sum up some of that information. If you have meteors that are smaller than a meter across, these guys are going to burn up in the atmosphere. We get little bitty ones that hit every single day. These things are very, very common, but they don't hit the ground. They burn up in the atmosphere, so there's no real effects of those. Between 10 and 100 meters, so let's say the size of a room or the size of a bus or, you know, a significant part of a football field. These guys may explode in the atmosphere. Some will hit intact. These hit fairly often, even as much as on a yearly basis, but most of them hit in the ocean, so we don't really notice what happens. Depending on how big they are and depending on whether pieces explode intact, you can get as much damage as a small nuclear bomb, like the one that hit Hiroshima. In the next video, I'll tell you about Tunguska. That's also going to be one of the ones that people are doing a project on, and this is a good example of what happens in that case. There's a very famous crater on Earth in Arizona called Meteor crater. Some of you maybe have even flown over it, like I have. This is when you have a 100-meter across meteor, and you get huge pieces that hit completely intact. Every 1,000 years or so, we get one of these. You make big craters with these guys, miles across, big craters. And you would get very widespread devastation, wipe out entire cities with these things. When we get to ones that are as big as a kilometer, we don't have a good example of this on Earth real recently, but we saw one that hit Jupiter, and really Shoemaker-Levy 9, you're going to find out, was a huge comet that broke into pieces, and each piece was about a kilometer across. If you're this big, you're going to hit intact, and you can get damage across the entire planet. You have major catastrophes, tsunamis, earthquakes, fireballs, all kinds of stuff. And then finally, the biggest ones. Chicxulub is the name of the one that killed the dinosaurs. I'll talk more about Chicxulub in the next lecture. I'll talk about it in some detail, actually, since nobody's doing a project on it. So Chicxulub is the dinosaur killer. And we get one of these every 100 million years. That's when you get mass extinction, wiping out huge numbers of species. It changes the climate. The entire temperature of the Earth gets cooler by several degrees for years at a time because of the dust that gets poured into the atmosphere that blocks out the sun. These are completely devastating. So this is what we're really scared of and what we need to investigate, how to deal with. So more about some of the historic ones in the next lecture.